Environmental pollution. Environmental pollution is the introduction of contaminants into the natural environment that cause adverse change. Pollution can take the form of chemical substances or energy such as noise, heat or light. Pollutants, the components of pollution, can be either foreign substances, energies or naturally occurring contaminants. Pollution is often classed as point source or non-point source of pollution. The major forms of pollution are air pollution, the release of chemicals and particulates into atmosphere. Common gaseous pollutants include carbon monoxide, sulfur dioxide, chlorofluorocarbons and nitrogen oxides produced by industry and motor vehicles. Photochemical ozone and smog are created as nitrogen oxides and hydrocarbons react to sunlight. Particulate matter or fine dust is characterized by their micrometer size. Light pollution includes light trespass, over-illumination and astronomical interference. Littering, the throwing of inappropriate man-made objects unremoved onto public and private properties. Noise pollution, which encompasses roadway noise, aircraft noise, industrial noise as well as high intensity sonar. Soil contamination occurs when chemicals are released by spill or underground leakage. Among the most significant soil contaminants are hydrocarbons, heavy metals, herbicides, pesticides and chlorinated hydrocarbons. Radioactive contamination resulting from 20th century activities in atomic physics such as nuclear power generation and nuclear weapons research, manufacture and deployment. Thermal pollution, this is a temperature change in natural water bodies caused by human influence such as use of water as coolant in a power plant. Visual pollution, which can be referred to the presence of overhead power lines, motorway billboards, scarred landforms, open storage of trash, municipal solid waste or space debris. Water pollution by the discharge of wastewater from commercial and industrial waste intentionally or through spills into surface waters. Discharges of untreated domestic sewage and chemical contaminants such as chlorine from treated sewage, release of waste and contaminants into surface runoff flowing to surface waters including urban runoff and agricultural runoff which may contain chemical fertilizers and pesticides. Waste disposal and leaching into groundwater, eutrophication and littering also come under water pollution. Let us now look at air pollution. Air pollution is the introduction of particulates, biological molecules or other harmful materials into the Earth's atmosphere, possibly causing disease, death to humans, damage to other living organisms such as food crops or the natural or built environment. The atmosphere is a complex natural gaseous system that is essential to support life on planet Earth. Stratospheric ozone depletion due to air pollution has been recognized as a threat to human health as well as to the Earth's ecosystem. Major primary pollutants produced by human activity include sulfur dioxides. Particularly, sulfur dioxide is produced by volcanoes and in various industrial processes. Coal and petroleum often contain sulfur compounds and their combustion generates sulfur dioxide. Further, oxidation of sulfur dioxide, usually in the presence of a catalyst such as nitrogen dioxide, forms sulfuric acid and thus acid rain. This is one of the cause for concern over the environmental impact of the use of these fuels as power sources. The next pollutant is nitrogen oxides. Nitrogen oxides, particularly nitrogen dioxide, are expelled from high temperature combustion and are also produced during thunderstorms by electric discharge. They can be seen as a brown haze dome above or plume downwind of cities. Nitrogen dioxide is a chemical compound with the formula NO2. It is one of the several nitrogen oxides, one of the most prominent air pollutants. This reddish brown toxic gas has a characteristic sharp biting odor. The next pollutant is carbon monoxide. This is a colorless, odorless, toxic yet non-irritating gas. It is a product by incomplete combustion of fuel such as natural gas, coal or wood. Vehicular exhaust is a major source of carbon monoxide. The next is volatile organic compounds. VOCs are also well known outdoor air pollutant. They are characterized as either methane or non-methane. Methane is an extremely efficient greenhouse gas which contributes to enhanced global warming. Other hydrocarbon volatile organic compounds are also significant greenhouse gases because of their role in creating ozone and prolonging the life of methane in the atmosphere. This effect varies depending on the local air quality. The aromatic non-methane volatile organic compounds benzene, toluene and xylene are suspected carcinogens and may lead to leukemia with prolonged exposure. 1,3-butadiene is another dangerous compound often associated with industrial use. Particulates, alternatively referred to as particulate matter, atmospheric particulate matter or fine particles, are tiny particles of solid or liquid suspended in a gas. In contrast, aerosol refers to combined particles in gas. Some particulates occur naturally, originating from volcanoes, dust storms, forest and grassland fires, living vegetation and sea spray. Human activities such as burning of fossil fuels in vehicles, power plants and various industrial processes also generate significant amounts of aerosols. Average worldwide anthropogenic aerosols, those made by human activities, currently account for approximately 10% of our atmosphere. Increased levels of fine particles in the air are linked to health hazards such as heart disease, altered lung function and lung cancer. Persistent free radicals connected to airborne fine particles are linked to cardiopulmonary disease. Toxic metals such as lead and mercury, especially their compounds. The next is chlorofluorocarbons. Harmful to the ozone layer emitted by products are currently banned from use. These are gases which are released from air conditioners, refrigerators, aerosol sprays, etc. Chlorofluorocarbons, on being released into the air, rises to the stratosphere. Here, they come in contact with other gases and damage the ozone layer. This allows harmful ultraviolet rays to reach the Earth's surface. This can lead to skin cancer, disease to eye and can even cause damage to plants. The next pollutant is ammonia. This is emitted from agricultural processes. Ammonia is a compound with the formula NH3. It is normally encountered as a gas with characteristic pungent odor. Ammonia contributes significantly to the nutritional needs of terrestrial organisms by serving as a precursor to foodstuffs and fertilizers. Ammonia, either directly or indirectly, is also a building block for the synthesis of many pharmaceuticals. Although in wide use, ammonia is both caustic and hazardous. In the atmosphere, ammonia reacts with oxides of nitrogen and sulfur to form secondary particles. Odors, such as from garbage, sewage and industrial processes, also contribute to air pollution. Radioactive pollutants, which are produced by nuclear explosions, nuclear events, war explosives and natural processes such as the radioactive decay of radon. Let us now look at water pollution. Water pollution is the contamination of water bodies, example lakes, rivers, oceans, aquifers and groundwater. Water pollution occurs when pollutants are directly or indirectly discharged into water bodies without adequate treatment to remove harmful compounds. Water pollution affects plants and organisms living in these bodies of water. In almost all cases, the effect is damaging not only to the individual species and populations but also to the natural biological communities. Point source water pollution refers to contaminants that enter a waterway from a single identifiable source, such as a pipe or ditch. Examples of sources in this category include discharges from a sewage treatment plant, a factory or a city storm drain. Non-point source pollution refers to diffuse contamination that does not originate from a single discrete source. Non-point source pollution is often the cumulative effect of small amounts of contaminants gathered from a large area. The common example is the leaching out of nitrogen compounds from fertilized agricultural lands. Nutrient runoff in storm water from sheet flow over an agricultural field or a forest are also cited as examples of a non-point source of contamination. Contaminated storm water washed off parking lots, roads and highways called urban runoff is sometimes included under the category of non-point source pollution. However, this runoff is typically channeled into storm drain systems and discharged through pipes to local surface waters and is a point source. Groundwater pollution. Interactions between groundwater and surface water are complex. Consequently, groundwater pollution, sometimes referred to as groundwater contamination, is not as easily classified as surface water pollution. By its very nature, groundwater aquifers are susceptible to contamination from sources that may not directly affect surface water bodies, and the distinction of point versus non-point source may be irrelevant. A spill or ongoing releases of chemical or radionuclide contaminants into soil located away from a surface water body may not create point source or non-point source pollution, but can contaminate the aquifer below, defined as a toxic plume. The movement of the plume, called a plume front, may be analyzed through a hydrological transport model or groundwater model. Analysis of groundwater contamination may focus on the soil characteristics and site geology, hydrogeology, hydrology and the nature of the contaminants. The next is noise pollution. Noise pollution or noise disturbance is the disturbing or excessive noise that may harm the activity or balance of human or animal life. The source of most outdoor noise worldwide is mainly caused by machines and transportation systems, motor vehicles, aircraft and trains. Outdoor noise is summarized by the World Environmental Noise. Poor urban planning may give rise to noise pollution, since side-by-side industrial and residential buildings can result in noise pollution in the residential areas. Indoor noise can be caused by machines, building activities and music performances, especially in some workplaces. Noise-induced hearing loss can be caused by outside or inside. High noise levels can contribute to cardiovascular effects in humans, a raise in blood pressure and an increase in stress and vasoconstriction, and an increased incidence of coronary artery disease. In animals, noise can increase the risk of death by altering predator or prey detection and avoidance, interfere with reproduction and navigation, and contribute to permanent hearing loss. The next is soil contamination. Soil contamination or soil pollution is caused by the presence of xenobiotic, that is human made chemicals or other alteration in the natural soil environment. It is typically caused by industrial activity, agricultural chemicals or improper disposal of waste. The most common chemicals involved are petroleum hydrocarbons, aromatic hydrocarbons, solvents, pesticides, lead and other heavy metals. Radioactive contamination, also called radiological contamination, is the deposition of or presence of radioactive substances on the surfaces or within solids, liquids or gases including the human body where their presence is unintended or undesirable. Such contamination presents a hazard because of the radioactive decay of the contaminants which emit harmful ionizing radiation such as alpha particles or beta particles, gamma rays or neutrons. The degree of hazard is determined by the concentration of the contaminants, the energy of the radiation being emitted, the type of radiation and the proximity of the contamination to the organs of the body. It is important to be clear that the contamination gives rise to the radiation hazard and the terms radiation and contamination are not interchangeable. Contamination may affect a person, a place, an animal or an object such as clothing. Following an atmospheric nuclear weapon discharge or a nuclear reactor containment breach, the air, soil, people, plants and animals in the vicinity will become contaminated by nuclear fuel and fission products. A spilled vial of radioactive materials like uranyl nitrate may contaminate the floor and any rags used to wipe up the spill. Cases of widespread radioactive contamination include the Bikini Atoll, the Rocky Flats plant in Colorado, the Fukushima Daiichi nuclear disaster, the Chernobyl disaster and the area around the Mayak facility in Russia. Thermal pollution is the degradation of water quality by any processes that change ambient water temperature. A common cause of thermal pollution is the use of water as a coolant by power plants and industrial manufacturers. When water is used as a coolant is returned to the natural environment at a higher temperature, the change in temperature decreases oxygen supply and affects ecosystem composition. Urban runoff, storm water discharge to surface waters from roads and parking lots can also be sources of elevated water temperatures. When a power plant first opens or shuts down for repair and other causes, fish and other organisms adapted to a particular temperature range can be killed by abrupt change in water temperature known as thermal shock. Let us now look at the effects of pollution. The human health. Adverse air quality can kill many organisms including humans. Ozone pollution can cause respiratory disease, cardiovascular disease, throat inflammation, chest pain and congestion. Water pollution causes many deaths per day, mostly due to contamination of drinking water by untreated sewage in developing countries. An estimated 500 million Indians have no access to a proper toilet. Over 10 million people in India fell ill with waterborne diseases in 2013 and 1,535 people died, most of them children. The World Health Organization estimated in 2007 that air pollution causes 500,000 deaths per year in India. Oil spills can cause skin irritations and rashes. Noise pollution induces hearing loss, high blood pressure, stress and sleep disturbance. Mercury has been linked to developmental deficits in children and neurological symptoms. Older people are majorly exposed to diseases induced by air pollution. Those with heart or lung disorders are at an additional risk. Children and infants are also at serious risk. Lead and other heavy metals have been shown to cause neurological problems. chemical and radioactive substances can cause cancer and as well as birth defects. Let us now look at the effects of pollution on the environment. Pollution has been found to be present widely in the environment. There are a number of effects of this. The first is biomagnification. Biomagnification describes situations where toxins such as heavy metals may pass through trophic levels, becoming exponentially more concentrated in the process. Carbon dioxide emissions. Carbon dioxide emissions cause ocean acidification, the ongoing decrease in the pH of the Earth's oceans as carbon dioxide becomes dissolved. The next, the emission of greenhouse gases leading to global warming, which affects ecosystems in many ways. The next is invasive species that can outcompete native species and reduce biodiversity. Invasive plants can contribute debris and biomolecules that can alter soil and chemical compositions of an environment, often reducing native species competitiveness. Nitrogen oxides are removed from the air by rain and fertilized land, which can change the species composition of the ecosystem. Smog and haze can reduce the amount of sunlight received by plants to carry out photosynthesis that leads to the production of tropospheric ozone, which damages plants. Soil can become infertile and unsuitable for plants. This will affect other organisms in the food web. Sulfur dioxide and nitrogen oxides can cause acid rain, which lowers the pH value of soil. Greenhouse gases and global warming. Carbon dioxide, while vital for photosynthesis, is sometimes referred to as pollution because raised levels of the gas in the atmosphere are affecting the Earth's climate. Disruption of the environment can also highlight the connection between areas of pollution that would normally be classified separately, such as those of water and air. Recent studies have investigated the potential for long-term rising levels of atmospheric carbon dioxide to cause the slight but critical increases in the acidity of ocean waters and the possible effects of this on marine ecosystems. Future climate change is expected to particularly affect certain ecosystems, including tundra, mangroves and coral reefs. It is expected that most ecosystems will be affected by higher atmospheric carbon dioxide levels combined with higher global temperatures. Overall, it is expected that climate change will result in the extinction of many species and reduced diversity of ecosystems. Increase in atmospheric carbon dioxide concentrations have led to an increase in ocean acidity. Dissolved carbon dioxide increases ocean acidity, which is measured by a lower pH value. Future ocean acidification could threaten coral reefs, fisheries, protected species and other natural resources. Large scale and abrupt impacts. Climate change could result in global, large-scale changes in natural and social systems. Two examples are ocean acidification caused by increased atmospheric concentrations of carbon dioxide and the long-term melting of ice sheets, which contributes to sea level rise. Some large-scale changes could occur abruptly, that is, over a short time period, and might also be irreversible. Another example of abrupt climate change is the rapid release of methane and carbon dioxide from permafrost, which could lead to amplified global warming. Scientific understanding of abrupt climate change is generally poor. The probability of abrupt change for some climate-related feedbacks may be low. Factors that may increase the probability of abrupt climate change include higher magnitudes of global warming, warming that occurs more rapidly, and warming that is sustained over longer time periods. Pollution control. Pollution control is a term used in environmental management. It means the control of emissions and effluents into air, water or soil. Without pollution control, the waste products from consumption, heating, agriculture, mining, manufacturing, transportation and other human activities, whether they accumulate or disperse, will degrade the environment. In the hierarchy of controls, pollution prevention and waste minimization are more desirable than pollution control. In the field of land development, low impact development is a similar technique for the prevention of urban runoff practices. Recycling, reusing and waste minimization helps in pollution control. With this, we come to the end of environmental pollution.